Hello students, myself Kiran TR. I am here to teach you an important and exciting topic in science, magnetic effects of electric current. Let's go. Electromagnetic induction. What is electromagnetic induction? In order to answer this question, we will perform two experiments. The first experiment setup is there is a coil consisting of many circular turns, galvanometer and a magnet. Galvanometer is a device which measures the amount of electric current or the electric current whether it is produced in this coil or not. Here you can see a needle which is there in the galvanometer. If the needle of the galvanometer, which is at 0, deflects towards the right, or if it deflects towards the left, this deflection in the galvanometer shows that there is current in the circuit. Now let us consider this experiment and see what it tells to us. In the first step, you have to move this magnet inside the coil. You have to move the magnet inside the coil. In the second step, you stop the magnet. So the magnet is stopped here. In the third step, you take away the magnet which is here backside. So let us consider this duster which I have as a coil, and let us consider this as a magnet. So the magnet is here, the duster is a coil. First step, move the magnet inside the coil. Second step is stop, so it stops. And the third step, you move the coil back outside. So there are three steps. Now in these three steps, when you perform, what are the observations that you do? First step. In the first step, you move this magnet inside the coil. Then you observe a momentary deflection in the galvanometer towards the right side. So the moment you push this in, the galvanometer deflects towards the right, showing that there is a electric current in the coil. Step 2. In the step 2, it stops. The magnet stops. So the galvanometer which is deflected to the right comes down to the center and it becomes 0. In the third step, you are taking the magnet out of the coil. So the magnet which is inside is moving outside the coil. So since the magnet is moving outside the coil, you will see a deflection in the galvanometer towards the left. The galvanometer deflects towards the left. So these are the three observations which you do in the three steps. Now, when the coil is not moving, that is the coil is stationary and the magnet is also stationary. When both are stationary, then there is no current produced in the coil. So the galvanometer will be at 0. So when both are stationary, there is no electric current which is produced. Let us see. Step 1. Move the north pole of the magnet inside the coil. So you are moving the north pole of the magnet inside the coil. A momentary deflection is seen in the galvanometer. Say right. So in the galvanometer, the needle deflects towards right. Stop the movement of the magnet. So when it is gone inside, you stop the magnet. The galvanometer comes back to 0. It has gone to right, it comes back and stops at 0. The deflection in the galvanometer becomes 0. Now, move the north pole of the magnet outside the coil. So you are moving the north pole of the magnet away from the coil. So there will be a deflection which will be seen towards the left. So this deflects towards the left. A momentary deflection is seen in the galvanometer towards the left. When both the coil and the magnet are stationary, then there is no current produced in the coil. Now, from this, what did we understand? We can conclude from this learning of ours that a moving magnetic field, a moving magnet or a magnetic field can induce current in a conductor or a coil. In this coil, there was no current, but this magnet, this moving magnet brought current into the coil which had no current. So we can conclude from this experiment that the motion of a magnet with respect to the coil produces induced electric current in the circuit, which is temporary. Until and unless there is movement, until and unless there is motion of the magnet, then only you have current, induced current. If you stop moving the magnet, then there is no current. Now we will move to experiment 2, and the setup of our experiment 2 consists of 2 coils. Here there was only one coil. Here you have 2 coils. You can see here coil 1, coil 2. The coil 1 is attached to a battery which produces electric current through potential difference and a key which you can on and off. Coil 2 consists of galvanometer. Step 1. In step 1 you have to on the key. The moment the key is switched on, the current will start to flow in the coil 1, and this current will produce magnetic field. So a moving current, the current when you pass, it has a magnetic field around it, right? So let us consider an example that I am here, 1 is me, second my energy, let us say my field of energy is still this much. So this is my field of energy and this is me. So there are 2 things, 1 me, and when I move, the energy around me also moves. Similarly, there are 2 things, 1 electric current, 2 the magnetic field around the electric current. 1. Now in this electric current, there is an electric current and there is a magnetic field which produces around it. Here you have electric current. When you pass electric current, what is being produced? There is a magnetic field which is being produced around the coil. So coil 1 not only has electric current, so when you switch on the key, it not only has current but it has also got magnetic field. So coil 1 has both electric current and magnetic field. Now this magnetic field in coil 1 moves. There is a movement in the magnetic field. This magnetic field moves to coil 2 and in turn induces current in coil 2. In coil 1 we have current and magnetic field. In coil 2, because of the magnetic field of coil 1, the magnetic field of the coil 1 produces electric current in the coil 2, which is shown in galvanometer, right? So the moment you switch on the key, when the key is on, the galvanometer deflects towards the right, and after instant there is a stop in the movement of the magnetic field, so the galvanometer comes back to 0. And when you switch off the key, again the galvanometer deflects towards the left and comes back to 0, right? So this is the experiment to define electromagnetic induction. In this, what did we understand? The magnetic field produced in coil 1 produces electric current in coil 2, right? Let us see. Step 1, pass electric current in the coil 1. You have to pass the electric current in the coil 1. So coil 1 now produces as electric current and around it has magnetic field. The change in magnetic field in coil 1 induces electric current in coil 2. So this magnetic field induces current in the coil 2, which is shown in the momentary deflection in the galvanometer. Let us say it moves towards right. Next, the current in the coil becomes 0. The moment you switch off the key in coil 1, there is a momentary deflection which is seen in coil 2, it say towards left, and then it comes back to 0, right? From this we can define electromagnetic induction as the moving magnetic field in a coil 1 induces electric current in another coil, or a magnetic field, moving magnetic field produced in one conductor induces electric current in the another conductor, which is called electromagnetic induction. A changing magnetic field in a conductor induces electric current in another conductor is called electromagnetic induction. If you love to learn more and need more of these videos, click on the subscribe button and the bell icon next to it. Don't forget to like, comment, share. Love you. See you in the next video.